The shape of the galaxy shown here illustrates, to some degree, in principle, the shape of the plasma environment in our solar system, though the density in the solar system is presently too low for the organizing plasma streams to be seen. However, by replicating the shaping process in the very small, in the laboratory environment, we can explore the forces that shape these types of phenomena. David LaPointe discovered in laboratory experiments that the primer fields, when they exist and are functioning, physically prime the environment of the solar system with a densely compressed sphere of plasma centered on the Sun. The principle is illustrated here. The effects, however, that David LaPointe discovered are so amazingly critical that great problems arise for humanity when their functioning is impeded or is collapsing. The evidence tells us that the dense plasma environment that is focused on the center of the solar system enables our Sun to be electrically powered from the outside by electric reactions. In these reactions, the condensed plasma interacts with the Sun's photosphere. The condensing process is a multi-staged process that is illustrated to some degree in the Red Square Nebula. The nebula is not the remnant of an exploding star, as nebulas are often regarded. Instead, it is an example of the type of features that we find in the primer fields in operation. The fields formed by the principles inherent in the flow of electric plasma in space. The details will be discussed later, though the overall effect is noteworthy here. The effect of the fields is that plasma streams that exist in galactic space in wide channels become drawn together, like by a wide funnel, and become magnetically focused from the funnel onto a central sun, or a system of multiple suns that becomes immensely powered by this process. The planets exist outside the densely powered sphere, on an ecliptic centered on the Sun between the two primer field structures. The plasma concentration process that we see in operation here, which is basically the same for every sun, renders our Sun as an intensely powered catalytic energy converter that is powered not from within, but is powered externally at its surface. The evidence that the Sun is externally powered is fairly obvious. When we look beneath the high-powered photosphere through the open space at the umbra of the sunspots, the Sun reveals itself as being much darker and therefore cooler inside. The photosphere has been measured at a whopping 5,870 degrees Kelvin, and the surface below at a mere 3,000 degrees. This means that the Sun's great luminance is electrically generated at its very surface and does not emanate from within, from nuclear fusion reactions, as it is generally believed. The plasma concentration process that enables a Sun to be electrically powered has been replicated in lab experiments. There, a highly compressed plasma sphere was formed in a thinly filled chamber of gas between two bowl-type permanent magnets that replicate the functional elements of the primal fields. The result, which is shown here, was developed by the function of the magnetic fields acting on the plasma flow to concentrate it. It is interesting to note that in the lab experiment, the plasma sphere at the center did not form instantly. The operating environment needed to be established first. However, in the real world, this establishing function also includes the forming of the bowl-shaped magnetic fields themselves, by which the plasma becomes concentrated. In the lab, the magnetic fields were provided with manufactured magnets. In the real world, the bowl-shaped magnetic fields are electrically created structures that are formed by moving electricity in space, in plasma streams. This means that the plasma sphere in which our Sun is located is the composite result of complex processes working together, for which a certain level of plasma input density is required for the forming of the magnetic pole structures to happen. I will illustrate later how the bowl-shaped magnetic structures are formed that furnish the primal fields, which in turn create the conditions that focus plasma onto our Sun, that lights it up to a great brilliance. While different types of atoms emit light in different bands, the numerous types of atoms that are created in the photosphere, in combination, create photons of all possible shapes and sizes that together cover the entire light spectrum and beyond in a seamless field of colors. The white sunlight that we see reflected in the color-rich world that we cherish is the direct result of the plasma fusion process in the photosphere of the Sun that is facilitated by the actions of the primal fields that focus interstellar plasma onto the Sun. The white sunlight with its colorful spectrum is not possible on any other basis than the plasma fusion process in the photosphere that synthesizes atomic elements of all types. The historically theorized concept of the Sun as a sphere of hydrogen gas with a hydrogen fusion process at its core is obviously false, because it cannot produce the white sunlight spectrum that we see. Hydrogen atoms emit light in only a few narrow bands. The white sunlight spectrum is only possible by solar surface plasma fusion, where all the known types of atomic elements are synthesized, which together emit the white sunlight. The color-rich white sunlight is clear, tangible evidence that we live in a solar system powered by plasma streams that the primal fields are an active element of, centered on the plasma Sun. However, the surface plasma fusion does not only create atomic elements and streams of light, but also emits highly energetic solar cosmic ray flux, marked 3C. Cosmic rays are not streams of light, but are events of highly energized individual electrons and protons escaping from the magnetic confinement of the primal fields on the surface of the Sun from the plasma fusion cells. Most of the solar cosmic rays are trapped in the corona that surrounds it, marked number 3. But when the corona weakens, more of them penetrate the barrier and reach the Earth. Solar cosmic rays have an ionizing effect in the atmosphere that enables the cloud forming process, which affects the climate on Earth. Increased cloudiness results in colder climates. The right top of the clouds reflects a portion of the incoming solar energy back into space, which thereby becomes lost to us. The top of the clouds also radiate latent energy from the cloud-forming process into space. Latent energy is released when water vapor is condensed into liquid droplets. When a pot of water is put on a stove and is boiled into steam, the energy that is invested in the process is released as latent energy when the steam condenses back into water. In the atmosphere, 45% of the thermal budget is derived from latent energy. Much of this energy is released in the clouds at the edge of the atmosphere, where much of it is cooled into space. By the combined effect of clouds reflecting solar energy directly back into space, and the clouds cooling latent energy into space, the rate of cloud forming is the major climate determining factor on Earth, and the rate of this process is absolutely determined by the Sun, by the volume of cosmic ray flux that escapes from it. When the solar corona is weak, which also results in weak solar activity, the solar cosmic ray flux is increased. Cloudiness is thereby increased, and the Earth gets colder. When this happens in a big way, a little ice age results. That's what we saw in the 1600s, at the time of the Maunder minimum of solar activity. The global cooling was so massive that rivers became skating rinks in the winter. That this time of the Little Ice Age was a time of large volumes of solar cosmic ray flux is indicated in carbon-14 measurements. Carbon-14 results from solar cosmic rays affecting the atmosphere. All the cold periods that we have measurements for were periods of weak solar conditions that result in extremely high rates of solar cosmic ray flux, and by implication also high rates of cloudiness. This means that the ever-changing climate on Earth is directly caused by changing density in the interstellar plasma stream, which, through the Primal Fields system, is focused onto our Sun. It also proves that the Sun is surface-powered by the primal fields, because no other platform than surface plasma fusion is able to generate solar cosmic ray flux, and this so massively as to affect the climate on Earth. It also means that the great global warming after the Little Ice Age is not man-made by industrial activity and fuel burning, but is the direct result of changing cosmic conditions that the primal fields have focused onto the Sun, where it affected the Sun's delicate operating dynamics. The recognition of these changing cosmic conditions is critical for our time, because we see in them a long-term down-ramping in progress towards another little ice age coming up fast, from which the solar system may not recover. The solar system barely recovered from the last little ice age. The down-ramping that we see suggests that the next minimum in the solar system may take us below the minimal density that is needed for the primal fields to be maintained. When the primal fields collapse, a phase shift occurs. Then all the climate changes that have occurred in the last 10,000 years will appear as nothing in comparison. With the sun going largely inactive, the glacial climate begins, that ice core measurements tell us will be 40 times colder than the world of the Little Ice Age had been. It has become self-evident in lab experiments and cosmic observations that when the input density of the plasma streams that feed into the primal fields system drops below a certain minimal threshold, the critical fields do not form, whereby the entire process stops. The climate fluctuations that have been experienced, that we have records of, tell us that the solar system is not as robust as it is generally believed and is down-ramping. When the phase shift happens in the real world, the brilliant photosphere of our sun is no longer being powered. It becomes, in effect, turned off. It fades into a thin haze, leaving in the wake a colder, darker, yellow sun that glows dimly by its internally stored up energy, like embers of a fire gone out, which too then slowly diminish. This means that the transition to the next ice age will not be a slow process that is drawn out over thousands of years, but will be a radical turn-off transition in which the sun goes dim in possibly a single day. There exists plenty of evidence in ice core samples that the kind of rapid transformation of the climate on Earth has happened that reflects on and off transitions from an active sun to an deactivated sun. Nothing short of such radical transitions can explain the massive, rapid cooling that occurred when the last ice age began 120,000 years ago. It takes a massive reduction in solar energy input into the Earth's climate to cause the formation of the enormous ice sheets that become spread across much of the northern hemisphere, as it is shown here, which piled up 10,000 feet thick or more in some places. When the phase shift happens, a radically different world unfolds. The actual time frame in which the phase shift unfolds may be extremely short, possibly spanning less than a single year for all practical purposes. We are presently near the phase shift point. We have come to the end phase of the actively powered period of the sun and the beginning of the next 90,000 years glaciation period. Of course, we don't know the precise day or year at which the primal fields will collapse, and the plasma sphere around the sun will vanish. But do we really need to know this? We know already enough to be inspired by it, to take the appropriate actions to build new infrastructures for our food supply and for our living. We know, with measured evidence on hand, that the Earth has been in a diminishing trend for 3,000 years already, that appears to be now accelerating towards the critical cutoff point. We see the solar system getting weaker. The telltale sunspot cycles are diminishing. Also, over the time frame of a single decade, NASA's Ulysses spacecraft has measured an amazing weakening of the solar wind pressure by a whopping 30%. This is an enormous drop-off for such a short period. We also know that when the sun's powered state ends, that is, when it gets turned off to a lower intensity state, the big ice sheets will form. It takes a big change in the incoming energy that warms our planet for big effects to happen. Let's hope that the cutoff point that we are moving towards is still more distant in time than it appears to be, because at the present time no one of humanity is prepared for the consequences. Not the least preparations are even considered to be made, much less are being made, even while the Ice Age consequences, when they do begin, promise to be far bigger than most people dare to imagine.